So x minus 2y minus 10 equals 0 is an equation in standard form, and so is the second one in standard form. So the first one I can solve for x, or the second one I can solve for y to make it easier. Okay? So I'm going to solve for x in the first one. So I rearrange equation 1, and I get x equals 2y plus 10. So by bringing the negative 2y and the 10 over to the other side, you get x equals 2y plus 10. Okay? Sub that into equation 2. And I'm going to call that equation that I just got, I'm going to call it 1 star. It's still equation 1, just in a different form, so I'll call it 1 star, and we'll continue with that notation later too. Okay, so sub into equation 2. So 3 times x, 3 times an expression for x that we just got there, the 2y plus 10, minus y plus 2 equals 0. Okay? Expanding, simplifying, solving, and we get y equal to negative 32 over 5. Now that would not be easy to find on a graph, would it? Okay, so negative 32 over 5 would be hard to graph. So this is where the power of this really comes in handy. We're able to get really perfect answers for this. Okay? Now we take that and we sub it into 1 or 2. I'm going to sub it into 2. You have to be able to work with fractions here to do this. So you've got 3x minus negative 32 over 5 plus 2 equals 0. Okay? That becomes a positive 32 over 5. Change the 2 into 10 over 5. Now we have a common denominator. Okay? And now we have 3x plus 42 over 5 equals 0. Bring that to the other side. Now divide by both sides by 3. When you divide by 3, it's like multiplying by 1/3, which makes this 5 turn into a 15. Okay, so you've got divide both sides by 3 means multiplying this side by 1/3, right? Dividing fractions, invert and multiply the second. Okay, so now we get the x coordinate is negative 42 over 15. The y, and I got this backwards here. Okay, so that should be a 42 over 15 there, and that should be a negative, and that should be a 15, and that should be a negative 32 over a 5. Forget about that 1 there. Okay, so that 32 over 5 is the y. I'll just write that neater. So negative 42 over 15 and negative 32 over 5. Okay, the next example here is this one here. Okay, same sort of thing. It's not in standard form either. You got the constants on the right with the variables on the left. Well, I'm going to solve here. I can solve for a number of things. I'm going to solve for y in 2. Okay. Another thing that you could have done is solved for 2x, or multiplied both sides of this by 2, and then you would have got a 4x on this side, and then solved for 4x and subbed it directly into here. Okay. I'm going to do it the hard way, but probably the most common way, and solve for y in number 2. So I rearrange it, and I get 2 star to be y equals 2x minus 1/2. Okay, so now we sub it into 1, so sub 2 star into 1, and we get this. Okay, so from the first equation, we've got 2 times x, 3 times y. Here's our expression for y. Sub it in for the y there, and equals negative 5. Now we simplify that, so we've got 2x plus 6x, I'm multiplying the 3 into both of those, minus 3/2 equals 5. And then so on. We just keep solving for x. we get x equal to negative 7 over 16. Okay, so when you divide by 8, you're actually multiplying by 1 over 8. It's a fraction. And you get negative 7 over 16. Now you sub that back into 2 star, which is up here. It's your expression for y. Sub the x into that. And you can now solve for the y coordinate, which you get is negative 11 over 8. Okay? And the solution is then negative 7 over 16, negative 11 over 8. That expression for y, and I get this one. It's not looking so nice now, right? You got the fractions again. Expand, put that 3 inside. So you get 2x plus 6x minus 3 halves equals 1. Okay. Then 2x plus 6x is 8x. Bring the 3 halves over. And 3 halves plus 1 is going to be 5 halves. And then divide by 8. So when you divide both sides by 8, you invert and multiply on this side, so it's times 1/8. Gives you 5 over 16 as the x coordinate. Okay, so not a nice looking coordinate. Now, sub that into 2 star. So 2 star was an expression for y. So I'm going to sub my x into that, and I get the y directly. So 2 times 15 over 16 minus 1/2 was 5 over 8 minus 4 over 8, all common denominators. And that gives me y equal to 1 over 8. So x equals 5/16, y equals 1 over 8. There's the point of intersection. So these next 2 examples are interesting cases. So in this one here, we're going to try and do substitution. So we assume there's an intersection point, okay, at least one. And we're going to sub the expression for y in 2 into number 1. Okay, so sub 2 into number 1. When we do that, we're going to have 3 times the y, so 3 times the expression for y, minus 2x equals 6. Multiply the 3 in. 3 times 2/3 is just going to be 2x. The 3's cancel out. 3 times 2 is 6, minus 2x equals 6. Well, 2x minus 2x gives you 0. And you end up with 6 equals 6. There's no x and no y in that. So this is a true statement. It doesn't matter what x and y is. You will always get 6 equals 6. So any points will work for this. That means that these 2 lines are the exact same lines, and all points on the line are solutions. The next example, 2x plus 5y equals 3. And this one, well, multiply 1 by negative 2, and then we get a negative 4x. Okay, so this is the trick I was talking about earlier. So now we're going to solve for negative 4x in the first equation. So multiply by negative 2 on both sides. We get a negative 4x in the first equation. And solving for negative 4x, we get this 1 star. Sub that into 2. So in equation 2, where we have a negative 4x, I'm going to sub this expression in. And then I'm going to solve for y. When I do that, 10y minus 10y is 0. And I get negative 3 on the left and 0 on the right. So negative 3 is definitely not equal to 0. So we have a false statement. This means our assumption that there was an intersection point is false. And there is no intersection, no solution. Okay? The lines are parallel.